Hello all, so this is the solution to the second question on the second homework for classical mechanics. So this question deals with what forces act on a person after he jumps out of a plane before and after he opens his parachute. So if we consider the case before he opens his parachute, so he's just in free fall, there are only two forces acting on him. The force of gravity, which is pulling him downwards. Gravity always points downwards. And the force due to air resistance, which we call drag, acting against the direction of motion. If he's moving down, then drag is going to act upwards. If the object is moving upwards, then drag is going to act downwards. It's always going to oppose the direction of motion. So specifically, this is the drag force for the shape of the person. Drag is highly dependent on the shape of the object it's acting on. So with these two forces, and a little bit of knowledge of a parachuter, he's going to be accelerating downwards. We can say that our net force is going to point downwards. So the second part of this question wants you to draw the forces after he opens his parachute. So gravity is not going to go anywhere, and the drag force caused by the shape of the person is not going to go anywhere. But we have a new force, a drag force of the parachute, which is likely going to be significantly larger than the drag force of the person. So now we have three forces to consider. So our overall net force is still going to be down. He's still accelerating downwards. If you add up the force of gravity and the two drag forces, you're still going to get a force pointing down. But this net force is going to be significantly smaller than this net force, because down here you have two forces opposing the force of gravity, where up here you only have one force opposing the force of gravity. So the final part of this question wants you to draw a diagram of time versus the force the person's experiencing. So the first thing I did when drawing this graph is I marked the time in which he opens his parachute, just at some random location. And I'm assuming that the parachute opens instantaneously, meaning I'm just going to have a bit like a step function, just going to be a sharp drop in the force, the net force when he opens his parachute. And we talked about why the net force is going to be smaller here. And so now the only question is what happens between him jumping out of the plane and opening his parachute, and then after he opens his parachute. So the way I like to think about this is if I write out my equation from a net force like this, you can see that gravity is going to be constant the entire time, assuming he doesn't change mass, which is an assumption we are almost always going to make in this class. But the force of air resistance, or drag, will depend on velocity. And obviously he's going to be moving faster the longer he's in the air. And so this force is going to keep getting bigger. This force will be constant. So overall, the net force will be going down the longer he's in the air. So that's why I have this drawn with a downward slope and this drawn with a downward slope. So this is by no means a very exact graph, and there's probably a more complicated relationship happening here, but this shows you sort of the general and basic features that happen here. So let me, Morten, or Jeremy know if you have any questions on this, and I hope this has helped you understand the problem better.